Okay, start recording again. So I did 8 minutes on mute. I'm sorry for that. Won't upload that because it makes no sense. But let me just give you a summary, and I have 10 more minutes. So it's all good. I'm just trying to think about the splitting because the splitting was off. I'm trying to understand how is it that we want to split this into heads. And my current thinking is that that's the way we should be doing it, not just num heads and depth. That didn't feel like... So X has this shape, right? It's just different numbers, but has this shape, 15 by 10. It has got 15 words, and each word has a depth of 10 because these are the D model dimensions. And so, but what we want to have is we basically want to have. That's my guess, is that we still want to have the 15 words, right? And then we want to have these dimensions split into two. So this split. Each of these elements split into two, but they're still part of the same. The first dimension, I think that's the way that it should be, and I think that should kind of work. And what the fuck is transposing now? Why are we transposing? Let's say if we don't transpose, does this break or not? That's the first thing that we want to see. It seems like it does. Where does it break? It breaks here. Okay. Most recent call has no attribute max length. We don't have max length. Then I guess it's just what we want to do. Of course, it's not max length. It's just we want to keep the first dimension, right? Cannot I just say is it len or length? Python array length is len. Okay, it's len array len x. Okay, so I think that's what we want to keep. Let's see if that doesn't break at least. Okay, that doesn't break. That's good. It doesn't break. So now, why split heads is doing a transpose? What is the... So walk me through. Can you walk me through an example of what the split head function should do, and why do we have a transpose call in the code? Okay, so that is actually, you see, that it's actually been, this is confirmed what I just said. Okay, so that's fine. Why are we transposing? So, I mean, it's essentially saying the byte size we're ignoring, the sequence length, that's fine. So in the n heads of shape, blah, 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 blah. And n is the number of attention heads. Well, since there's the number of tokens in the sequence, versus the size, that's all good, that's all good, that's all good. Okay, so this we at least got right. And in this example, we create a random input tensor of shape 2, ignore the batch. 10, 16 into 4 heads along the last dimension by reshaping x to 2 stays the same, 10, and then it's like 4, 4. And then transposing it to have shape. I guess what we're trying to do is we're trying to transpose it so that the dimension, so that here we've got the heads. I guess that's what we're trying to do. Yeah, exactly. That's what it says here. So byte size num heads. Okay. But that's like a 4-dimensional transpose, right? Like I'm just familiar with the transpose concept, like in just matrix. where you flip columns by rows and stuff like that, that the transpose in this kind of case is pretty crazy. So I'm assuming that it's going to just work well. Although I have that kind of urge to just take a look at a concrete example, but I'll maybe do this next time. So it's just a reordering of the dimensions. So I guess this is, because we are ignoring batch, I guess what we're gonna do is we're gonna just say this is, I assume is 0, 1, 2, so this is 1, this is 2, and this is 3. Yeah, that's what we're flipping these dimensions. So we're flipping dimensions. I guess so that we can then build the loop that iterates over these things better, or the multiplication better, I guess. Well, yeah, just the fact that, you know, we want to be able to split this then later, I guess. This part here that basically does, so the call does these, and then we're splitting, but then nothing else happens. Oh no, then this part here, the scale to tension stuff. Okay, so that's next time. Okay, so that's the next thing that we're doing. So I guess we're just doing it so that the multiplication, then it's easy to for this to happen. So we're just splitting these heads and then putting this dimension forward. That's very mathematical. I'm just trying to make sure that these steps make sense intuitively. It's just technical, as in like how to process the data later with, you know, making the use of matrix multiplication. So let's just a brief recap again would be that you're doing a you have the input sentence. You wanna, again, we're breaking it into 2 heads in our example because then you parallelize that, so you make sure the GPUs or whatever the hardware is that does the multiplication can do this in parallel. And I guess you're then, but you need to do the transpose so that you can concatenate this stuff later, or what? Because you're redoing another transpose. I don't really know what comes next, but I guess I guess you need to actually then calculate dot product attention. Oh yeah, that's the next part, to understand what that is. And this is where there's even a softmax here with attention weights. Okay. Give you, so the multiplication, another transpose of the axis. Okay. Cool. That's gonna be fun. If mask, so this is gonna be fun, but I guess it's just what we're doing. So let's hope so. Let's hope that ignoring the batch hasn't been a bad decision, and that we're just doing like one sentence at the time for now. So, you know, it kind of so far still makes sense, and then we can adapt the code to add the batch. I think that's going to help us as well to understand a bit how the code is really organized. But yeah, we're reshaping it like this, and then we're doing a transpose. I guess it's 0, 1, and 2 because it starts with 0. Anyway, that was a short one, but at least we moved on. That was just this is just a technicality. So at least now it's not breaking, which is good. It's not breaking. That's perfect. That's perfect. Oh, maybe let's just print the shapes again. See what are the shapes that we've gotten in here, just to confirm that it's actually doing stuff. It's a shape of 15, but it doesn't. It hasn't done the transpose. Oh. So we won num heads here. So one, and we won this here. Sorry. Now that's correct. Now that is correct. Yeah, now we have this. So we essentially have, yeah, that's good. So you have basically the 2 dimensions, the 2 heads in here. So, you know, for one head, then we have the 15 words and 5 dimensions. And then for the one thing is we're just returning one. Okay, so but we're returning. Okay, so what the fuck here? But we are returning only one of the heads. You know what I mean? Like, where's the other? Should be. Oh no, that's fine. Stupid. Because that's why you have this dimension. That's why you have these 2 here. So if you imagine accessing that as an array and say that's the 0 element, it's got the 15 words in the first 5 D model dimensions. The 1 element, sort of the second element, it's got the 15 words again, and the second 5 elements. Okay. I'm not so sure why this then helps with the GPU stuff, so it might be interesting to understand why does this help. So I'll add another to do, because I guess this is what then gets parallelized. So to do, is this what gets done in parallel at GPU level? And if so, how? I think it's just thanks to the fact that we've shaped it like that, I think. Let's see. Thank you.